if a to the negative 1/2 equals x, where a is greater than 0 and x is greater than 0, which of the following equations gives a in terms of x? Another question where we have to rewrite an equation in terms of a different variable. So we want to get this as a equals. So let's deal with the left side here. We've got a to the negative 1/2 equals x. Well, how do we go ahead and get rid of the to the negative 1/2? Well, what we can do is raise both sides to the negative 2 power. Because by your exponent rules, when you raise a power to a power, you multiply them. And negative 1/2 times negative 2 gives us 1. So we get a to the 1 on the left, which is exactly what we wanted. But then we have to apply the x to the negative 2 on the other side. Let's make that negative exponent into a positive 1. Remember, you do that, very important, by flipping it and making it positive. So x to the negative 2 is the same thing as 1 over x squared. So we're going to write 1 over x squared, and that's choice B, and that's the answer. Now, there are other ways to tackle this question. You also could remember that a to the negative 1/2, we can make that 1 over a to the 1/2 equals x. You could also remember that a to the 1/2 or anything to a fractional exponent is going to be some sort of square root or cube root. In this case, a to the 1/2 is the same thing as 1 over the square root of a equals x. Now we could square both sides. We would get 1 over a equals x squared. Do a little rearranging and we get the same answer, a equals 1 over x squared. I think this is the most direct and easiest way, though. So if you know how to do this, it's not that bad. Answer to this one is B. This is a question where you need to not only know your exponent rules, not only need to know what a negative exponent is, but also remember what a fractional exponent represents. So there's a lot going on in this one, a bit beyond what the original old SAT did with exponents. A bit more, again, traditional. You know, you've probably spent time in your Algebra 2 class, perhaps, going over these types of exponents. So indeed, they're tested here. Knowing this shortcut really makes this question pretty straightforward. If you don't know that and you have to do it these ways as I described here, it's a bit more work. I don't think it's much harder, but it's just a bit more work. You also, in theory, though there's no, I was going to say you could plug in here, but given that you don't have a calculator for this particular section, it might be a little annoying. Because if you know, for example, if I put 16 in for a, if you know how to deal with that, if you know how to raise that to the negative 1/2 power, and then get an x out of that, and then see which choice works, if you know how to do all that, you might as well just do it algebraically. So plugging in, actually, I don't think is very viable here. But yeah, so know your exponent rules, and that's the same from the old SAT. It's very important, in addition to being comfortable with negative exponents and fractional exponents.